All right, thank you all for coming. My name is Arshan Dabirsiaghi. We're going to talk about automatic code fixing and remediation and self-healing software. And through that, I'm going to tell my story a little bit. So when my story is like a lot of people here, I'm sure. When I was a kid, I thought it was the coolest thing in the world to take over somebody else's computer against their will. I'm still convinced there's nothing cooler than that. And then when I actually I did AI in university because there was no security in university at the time. But then when I got out of college, I found, oh, you could do this for a job. And I got into AppSec. That was sort of the local opportunity for me. And so I was doing code reviews and penetration testing and architecture reviews and developer training. And it all felt very one-off. And so I tried to use static analysis with my consulting companies to try to scale security, but the signal to noise ratio was not helping them succeed at the tools I had at the time especially. And so I looked at my partner, Jeff Williams, who was the chair of OWASP for many years. And I said, can we do something different? So I started a company called Contrast Security with him that is a runtime analysis tool. And runtime analysis tools, you see data come into the system and then you see it reach a SQL call, without any parameterization or encoding or validation, and there's really no arguing about it. That is a true, very likely a true positive. And my expectation was that I hand you the thesis of Contrast is I want to hand you 20 or 100 things, not 5,000. And so that company did well. They're still going, but I became obsessed with the idea that by giving you 100, the amount that get remediated should be near 100%. And what I found is that the journey after you find something is still way too long, error-prone, manual, culture, sort of tension-producing. And so, I wanted to take a shot at that problem. So that's what led to a lot of the research that we're going to talk about today. And so I tried to go back and sort of think about, where we've been and where we are and where we're going. So I tried to go back and research, what was the first time we had code that changed code? And the answer shocked me that the Fortran compiler actually rewrote your code in order to make it perform better on certain hardwares. And that is so cool that they were doing that in the 50s when they had, you thought you barely had two sticks to rub together. The first transistors are being put out there, and they're already doing that. Smalltalk community had a lot of interesting ideas, and in the 90s, they were the first ones to have what I'll call directed refactoring tools. So you could click on a method in a visual IDE and make a change that's sprawled across your code base. And so that, obviously all the IDEs of today have that. In the late 2000s and maybe early 2010s, the linters started fixing things. So you would have very low context changes, very simple things that they would fix. Eventually those things moved into the pipeline. And what I'll call first generation code mod libraries then started to be born. CodeMod was one put up by Facebook. And then, we had other more academic things like Spoon for Java. And so we started to have these things that allowed us to have more sort of concrete syntax changes rather than just some abstract syntax changes, and allow a little bit more expressive changes. In 2020, totally sort of flew under the radar. I thought it was a really good accomplishment for the time. There was a bot cooked up by a Brazilian team that just fixed Sonar linter issues. Their research showed they deployed it in a company in Brazil, and they found that they fixed 60% of the things that the bot recommended, which is a good number, 60%. If you compare it to some of the other types of tools we have today, like if you compare it to Copilot, all the studies say Copilot, you accept around 20 to 30% of the changes that it makes. And of course, this was pre sort of generative AI era really taking off. And then there was a second wave of code mod tools, Open Rewrite and Code Modder and JS Code Shift, really sort of new version of it that really open up the expressiveness of the capabilities. And then, so that's where I'll cut off the past. And so these are the kind of simple, this is a very, obviously the most simple example you can have. We have an extra semicolon, and so it's easy to make a changer that makes this change. So we try to classify these changes. It's a simple change to make. Turning code into code prime is not very difficult, but having just that expressiveness doesn't allow us to change too much, right? Hard to fix SQL injection with that type of tool. But on the other hand, we have super high confidence in what we're doing. You could apply these changes without looking at them. So let's take a look at the present. And so again, my goal is to have self-healing software. And so when I start with that goal, I look at all the academic work for how people model self-healing software. This is the graph you get, and this is the diagram you get. And so I try to build this, and I think I'll have some shared empathy here with other people who are trying to do this. What really happens is, because the tools are so noisy with false positives and things that shouldn't be fixed, you'll end up fixing a lot of non-bugs. And so what happens when you do that? You're going to have security, performance, and quality problems that come out of that. So this is a very simple example. The tool reports across a scripting vulnerability, and then you fix it, and then what do you get? You'll get multiple encoded things. So this is a very innocent example. Nobody got hurt. But you can imagine scenarios like if you double escape a utility that's doing escaping, you're right back to where you started. And like if you would try to escape SQL strings, if you do that twice, you're actually right back to the vulnerable state you were in. So this is going to be a problem. So what I tried to reframe the self-healing software into something that made sense. And so I think about it like a funnel. And so if you think about the top of the funnel, the first question is the bug report accurate? So 50 to 80% of the things that come out of static analysis, depending on which study you do, are false positives. And some are obviously way worse than others. And some find lots of linter things, so those are not really false positives, so it drives their accuracy numbers up. But really, on the security issues, is a very high false positive rate. We'll talk about why. And so massive problem right at the top of the funnel. What is the actual severity? Because if you don't know what the actual severity is, not all bugs are the same. Your security team doesn't think about them the same way. Your developers don't think about them the same way. So how do we, knowing the actual severity influences the outcome and the reporting and everything else. What is the safe and effective fix? So being able to take an issue and creating a safe and effective fix is obviously a super important part of this. And as a technology person, of course, that's where I started. And I'm only focused on that. And then you try to turn it into a real world product and solution and solve it for the industry. And it's like, well, that's important, but it's not everything. But what we can do today here with a combination of tools is really good. It's really good. People don't realize sort of where we are with this, what's capable. If you wanted to have self-healing software, if you want to have a bot heal itself, heal its own code, well, you need to have bots sort of checking its own work, right? Most financial companies have maker-checker rules, right? Where somebody wants to issue a wire, another person has to approve it. We all have this in our enterprises. If you want to submit a PR, somebody has to approve it before it goes in. And so we don't really have this capability yet from a compliance standpoint, let alone a technology standpoint. And then retesting is also a little bit problematic, manual. It's expensive to re-kick off a scan for some types of scans. If it's a bug bounty, even if it's a heavy static analysis, that's going to be a problematic thing. If you want to fix one thing, rescan, and if you want to fix 1,000 things and rescan, of course you're going to run into issues. So this is what I think the real self-healing software world looks like, and I think we're some distance from this, but I feel like at least I've got a categorization that maps out where we need to go. So the first big problem, again, on this list, the massive bleeding from the neck problem in self-healing software, I think is triage. So you won't find me saying a lot of positive things about CodeQL, but on Microsoft's campus, I'll use a positive CodeQL example. This is, I like how CodeQL identifies insecure randomness. In this example that it's cited on an open source project, it's saying, I don't know if I have a pointer here, but it's saying there was a random string that was passed to an API that has the word password in it. So they've turned it into a taint flow sort of rule. And so this looks really good for a finding, like compared to other tools which would just report the presence of an API which generates insecure randomness. This one's saying, hey, look, you got to send it to something that takes a password for it to be considered vulnerable. But actually, when I went to diagnose this issue, I found that there was a little bit more to it. And so in this case, the random string utils library is vulnerable. It is an insecure source of randomness until version 3.15.0, in which case they switched the internals of it. And so from then on it became, this is now a false positive. And so I've had a lot of experience diagnosing these types of things. Lots of developers, they would look at the bug report, even security people would look at the bug report, say this looks like a real issue, go off to chase it down and fix where there may not need to be a fix. And so there's a ton of triage that needs to be done, and there was not a solution for this before the era of Gen AI, because I think your first reaction might be, we need to improve our static analysis. But static analysis actually can't solve a lot of problems like this. There's lots of reasons why, the rules are very rigid. It's like API data came from API A and it got to API B. But there are a lot of times the control, the missing security context that would inform that rule is not in that line. And so for them to try to re-architect their products to look in those different places is not straightforward. And so this is an issue that there are on the market, multiple products that can do triage using AI. And so this is an example of one. So in this case, this commercial tool that I'm associated with that does, runs the investigation to look up what is the library that is used in this project and decide if it's vulnerable or not. So the gates of what is possible with AI is really exciting. I think Eitan gave a good talk this morning about some of the risks there, and so I think we won't belabor all of those, but we'll talk about it a little bit. But we think that there's a lot of ways that AI will reshape and help us in the industry, and I'm really excited about triage. I think it's one of the most exciting things going on. But let's talk about fixing now. So this is in a library called Open Rewrite. It came out of Netflix. It's now been commercialized into a company called Modern. And so it is a pretty high barrier DSL for, they call them recipes, in order to take code that's like A and turn it into A prime using a lot of their, not proprietary, but language recipes that are very specific to them. It's mainly focused on modernization, which is good, and there's some security sort of tailwinds there if you're modernizing your code. But this is open source, it's deterministic, it's not AI, but it's found some traction in the developer community just because it solves some of the problems that are really not security specific. This is CodeModder. CodeModder is an open source project that we write. And so it is really built for, it's really an orchestration layer of, we take, and this is all open source, you can go see it, take results from different tools and stitch them together with libraries that are really good at making refactors like JS CodeShift or Java Parser, and just making that contract, fulfilling that contract of fix thing from tool with good reporting really, really easy. That's the whole purpose of the library. And so the change you see here today is, this is a change that does, fixes SQL injection. So we've clearly come some distance from the linter fixing error where we can only fix, very small things. And this is just, deterministic. So now let's talk about AI. Has anybody used Aider? Okay, not that many. I know we're a security place, not a developer place. How about Cursor? Okay, a little bit more Cursor. So Aider is like command line version of Cursor. It's a pair programmer, and it'll do whatever you want. It'll try to do whatever you want. So you can say, give me, here's a file that's got some data. Draw me a model of the data. And you can ask it to do cool things, and sometimes it will do them. But it is, if you use it for more than 5 minutes, you're going to find the impact it can make on a existing software project that's full of your custom business stuff. It's hard to navigate. And so if you try to just take AI and throw it at the problem, there are too many failure modes to enumerate here. If I'm very generous and I say each one of these roadblocks has a 90% success rate, hallucinations, it's got out-of-date information, it injects things we don't want it to, it breaks contract. Hell, even just asking for a diff, diffs are hard to calculate for a language model. There's arithmetic involved, which they're not particularly good at. It's very, there's nested encodings there, so it's tough. And so if you're super generous, more generous than I should be, let's just say you have a 30% success rate of generating a single shot fix. And one of the ways that we're getting better at using AI for fixes is by just throwing a shitload of tokens at it. And how does that work? You might have 3 different tries at making the fix, so you just spam it 3 times, and maybe you take whichever one, you use an evaluator, figure out which one is the best. You can feedback, so if you evaluate it and you don't like it, you can say, I like it, but I just didn't like this part, so let's do it again, so you can get into loops. And you start to form these agents out of these graphs that you're building of controlling the LLM behavior. And so this helps, but there are of course still limits here. So this is what Cursor is really good at. If you've ever had had experience with Cursor, and by the way, it's really worth trying Cursor. Just go and play with it, ask it to make changes, and the way you watch it think and operate, it really is going to fundamentally, I think, change your estimation of where AI is going. But I say don't be fooled, because you can't just let it run totally loose. You'll see, I'll come back here. You'll see great demos. You'll see LinkedIn influencers say, I gave Cursor the game of Pong. I said, go make Pong, and it made Pong. And it's like, look, that is absolutely stunning. If you had told me that 5 years ago that was going to happen, it would be hard to believe, and it is a modern marvel. But at the same time, the Pong is baked into the weights of the large language models, right? So it knows we talk about Pong, there's videos of Pong, there's a lot probably like examples of Pong code out there. So that is just baked in, the models know how to do that. if you try to make changes that are a little bit more specific to you, to your business, to your apps, you're going to end up with a very different experience. You may suggest to the machine like what you think are very simple instructions, but it doesn't know what other context in the code base it needs to go grab in order to make an effective change for that. And so even the state of art is amazing, but it's not good enough to just place in line, generically in a pipeline and just say, go issue PRs for this. And of course, just an example I saw today from a great blog. The user had a request to add some sparkles to their bug fix, not a security bug, but just a bug fix. And the Vibe coder said, give me magic sparkles from this magic sparkles library. The only problem is that library does not exist. It just predicted that that library existed. And so obviously there's squatting risks and there's all kinds of risks. Again, 10 a.m. this morning there was a good talk about all those risks. Another quick idea of how to help you generate more deterministic AI stuff. Imagine you ask for if you ask for a diff, again, asking the diff, you're asking the LM to encode your data inside of another, it's 2 layers at least of encoding, and heaven help you if you have actually encoded data in the code you're changing, you're asking it for a lot. It can't maintain all that state in your sort of next token prediction. So it's just a complicated language, the wrong language to talk to this person with. But you can imagine a different language that I know that is easy for them to speak. So hey, give me a set of instructions on what to do here, and hey, remove the statement on line 139, or add a string parameter here. So this is one way, if you want to truly fix things with every different tool, you need to be able to do this kind of thing as well. Learn how to talk to the partner. This doesn't address all those issues that we talked about, it just addresses some. So it's also interesting to think about, we have so many issues in our backlogs. Every company, every enterprise has hundreds of thousands or millions of things in their backlog. And I think you can help significantly even if you just stay within what we call the low blast radius issues. And so this is an example of XML external entity of vulnerability. I'm sorry if you can't see that, but the fix here is to prevent this attack, which allows exfiltration and remote code execution, is to just turn off the allowing of external entities. This external entity feature, it's almost like it was written by an attacker for attackers. There's really no utility. Nobody would ever do this on purpose. And so, I'm very confident I can make this fix, and nothing bad is going to happen. On the other hand, and this might look familiar, if I change your hashing library from MD5 to bcrypt, which is a change generally that we all want, what's going to happen? The app is going to break. And that's because all our existing hashes are bcrypt or MD5, and so we haven't updated those existing hashes. And who knows, this may be how we talk to partners. So I would take completely the other side of the bet. I'd pay you $1,000 if this doesn't break something. So the code, the complexity of the code change is oftentimes not sometimes is not the gating factor, right? There's other factors at play. And so what can we do today in this self-healing, part of the stack that's really about automation, in triage and fixing? So we did a case study. We released some of these case studies already. If you take a look at just top of funnel, give me all the bugs. Our experience so far is that we can triage around 50% of the things, 50 to 60% of the things, to either this is a false positive, or the severity is actually much lower than is being reported. And then around 40% of the things can just be fixed. And you could do a study that make these numbers say whatever you want, because you could pick a tool that has is more on the linter side, and then you can say, I can fix 80% of the things. And so we try to be very fair to the bigger box static analysis tools that are more focused on security. So I think we're in a good place right now, and we're in a good place to iterate and continue to keep driving these numbers up as an industry. We'll skip this. So let's talk about the future. And so this is where we find out who's an optimist and who's a pessimist. Of course, there's going to be some speculation in this section. You never know with language models. Is there going to be a next improvement? Is the next improvement going to be incremental, or is the next improvement going to be fast takeoff towards AGI? And so it's a little bit hard to get a read on the future of LLMs, sort of in their fundamental reasoning capability. How much reasoning can you encode into weights of a single-shot LLM call? If we judge based on the behavior of the frontier model companies, they're not trying to train GPT-5 with an order of magnitude more data, because I think that they've reached some local maximum. So if I look at what I think they think we have to start using LLMs more as a primitive rather than a solution of its own. And so DeepSeek R1, the O1, O3 models are really, you're asking the model to think, go think, and then come up with an answer. So if you can imagine, a system where the individual LLM is as small as a transistor, like how intelligent could that system be? If you have a transistor-sized element that has its own tools, has its own memory, has its own agency, and then build a system, scaled out of those, it seems to me that we can get to a very intelligent behavior. It almost seems inevitable, actually, that we can get to really intelligent behavior. So a little bit of speculation on my part, but I think we've seen enough with MCP and reasoning models where, I don't know, that's where it looks like it's going to me. But then if you ask Sam Altman, Sam says there is no wall, we can just throw more data at it. But that's not what I've seen their behavior to be. And so LeCun from Meta, who's like one of the modern, fathers of modern generative AI, he says like LLMs are just the wrong tool in order to get to AGI. And I'm not qualified to say whether that's true or not, but I almost think it is a distraction, because what is possible with the LLMs today, just figuring out how to use them together and correctly, I think is going to be enough to build very, very intelligent systems. And so if we're going to create more intelligent systems, how is that going to lead to better fixes? Well, I think, if we want to make more ambitious fixes that can do things like fix MD5 to bcrypt, we're going to need the same things that a developer would need in order to make those fixes. You don't just, give a developer an IDE and say, go fix this Jira ticket. You onboard them. You onboard them with, you give them access to Notion or Confluence or whatever, and you ask them to, go use these systems, learn more about the things, ask people, and you end up at a very different, that's how you get different behavior. So what might a next-gen fix look like? These are just, obviously, they can look like any arbitrary code. So a automated software engineer that makes fixes would look at the failing CI build and say, it's failing 3 times with out-of-memory errors. For this fix to actually take hold, I need to increase the memory. And it can't do that without access to the tool, memory, deep inspection, And so that's the kind of thing we're looking for there. If you wanted to change a, like a method signature in order to fix a vulnerability, well, you really need the call tree, right? So you need to inspect the wider graph of the application. So we can expect that as well. And then, of course, it needs to ask for help, because sometimes the answers are not in the code. Sometimes the answers are not even in documentation. They're in like the one team member you have that's just been around for 10 years and knows everything. And so in those cases, we need to find that person and ask them. So if I think about what is going to, what's going to drive the next level of fixes, and maybe this is 2 generations away, is who is the best at filtering all of this data on the left here, turning that into a meta sort of cognition level, and then turn that into, and do something great with the fix. So, in the IDE space, Cursor's done this pretty well, but Cursor is still, mostly looking at the code. Now they've created MCP plugins where you can actually give Cursor access to other AI services. And so it'll be interesting to see how far they can take that. So this is where I expect the solutions to be. Okay, so if I just up-level this into a few takeaways of what are we going to see, I think we're already seeing companies that are using intelligent systems to drive to remediation. AppSec, I've been in AppSec for 20 years. It has always been about detection, and the prevention has always been, around where boom happens, and we're usually before boom. But I think that these tools give us the ability to create remediation solutions. I happen to believe, this is sort of an aside, I happen to believe that fine-tuned models are not that useful. As developers, you know that your code changes all the time. And so fine-tuned models are kind of a distraction, I think. If you fine-tune a model, you have a bunch of data that goes in, and you have a classifier. It's a very expensive pipeline to build, and your code is always changing. And so if your fine-tuned model needs to change, you need a bunch more data to sort of rebuild that feature into the data. And so it's a very expensive way to operate. And so for all the for all the talk about fine-tuned models, when I talk to people, they're really not that. I'm really not seeing any of it. And so I think reasoning models are going to, and obviously RAG and other stuff will help create much more useful stuff. And by the way, some of these are, we're already seeing happen. So a dramatic rise in the percentage of things that will be fixed by bots. And this will be weird for people. People's muscle memory is not built around this. I think tools like Dependabot, Renovate, have really changed people's behavior about, it's okay to get feedback from bots, but first-party code, that has not really become the norm yet. And I think it will be. And of course, Gartner's going to figure out how to make money on this somehow without contributing really meaningfully. That's it. Thank you very much. All right, happy to answer any questions. Yeah?
Early in the talk, when you were speaking about the history of contrast and how the verified, exploitable kill chain you thought would drive remediation, can you elaborate on why it didn't? I know it's off topic, so you can talk about it offline.
I should say it did, but not to the grandiose dreams I had in my head. Okay. I thought, it would be, 100%. There's no arguing about it, right? Like, you sort of have this very, like you say, kill chain. You have this very visible chain. But a lot of times, you wonder who really holds the stick in these companies, and developers hold a lot of, the power still, and the tension. There's been a lot of cultural damage done to that relationship. Look, frankly, by static analysis tools. if I'm being honest. And I think you probably, I hate to say that, I know there people are here, but if you throw results at developers, where it's a 99% false positive rate, and some tools literally have that, then of course developers are going to sort of culturally reject security. I mean, never going to trust you again. And so I think that was a big part of it. Just we need a little bit of a reset to reset the relationship between security and developers. And so, I'm hoping that tools that are a little bit smarter and offering remediation is one way to get there.
The code assist tools that are being used now, and as you build new applications, do you see any shift in the quality of code, and you see less vulnerabilities, or do you see any change in pattern?
Yeah, good question. So the question is, like, are the new code generation, like Copilot and Cursor, how are they changing the quality?
Yeah.
So NYU and Microsoft and others have done the studies, and the results are very clear. The vulnerability density is the same or higher, and paradoxically, developers have more confidence in it at the same time because the code looks good.
It's worse.
What's that?
It's worse now.
The situation is undoubtedly worse. And you think about in your development teams, like there's developers who give great pull request feedback, who really think deeply about your stuff. Those are actually the good vibe coders because the model is changing from code writers to code reviewers. And so if you can't review code, if you're not willing to put the effort into review code, which is an order of magnitude harder, then you're going to ship whatever you want to ship. And so we use Cursor internally at my company, and you have to be diligent in your review. I'm very lucky to be able to hire some great engineers, but I've caught it before, like a test case is failing, and instead of trying to fix the bug, it goes and it changes the test case to just make it work, and in ways that are like, obviously I don't want that, but like, it's like Asimov's 3 laws here, like the easiest, it finds a path to solution that is somehow involves your destruction. And so yes, in my opinion, my experience, what the studies have said, it's going to be as bad or worse. And another 2 points along that path. For an LLM to really understand whether a vulnerability is an emergent phenomena across your code base, right? So, event 1 could be over here, event 2 could be over there, and event 3 could be over here. So if the LLM's just editing this, it doesn't know, right? It's not keeping that call graph in its head all the time, and that's just, LLMs are just not a good store for that. And so even if you make it very fancy, very agentic, I don't know how you encode, I don't think you can encode that. So I still think there's going to be a strong need for tools to run after the code has been committed to find issues, and it is going to find issues.
And accountability also will be shifting a little bit because now it's generated through tool versus developer in some of these cases.
Yeah, I mean, I happen to think somebody needs to sign off on the change, and when I use Cursor, I'm signing off on the change for the bot, like it's my responsibility. And so I hope everybody feels the same way, but we'll see. But I think in the short term, it is impossible for companies to ignore the productivity gains that are coming out of these tools. When Copilot was first analyzed by McKinsey, they said like the autocomplete Copilot, because now GitHub calls everything Copilot. They said it was like a 20% productivity gain. The studies have not come out yet, but Cursor is obviously a 300 or 400x, 300, 400% improvement. It's just not even close. So it's at least an order of magnitude more productive, more productivity. So I don't anticipate any lack of bugs in the future. Is anybody an optimist on the security of the code going to be is going to be better? Yeah.
You can build out call graphs pretty easily these days, right? Like feed it into an LLM as part of its context.
A data flow call graph is quite expensive to put together.
Yeah, but like, okay, so here's an example, right? I have a function, I want to figure out where it's called, in an IDE, a regular IDE, I can go in and say, find all references, right?
Yeah, and recursively do that.
Right? So like in theory, you're able to generate that information on the fly in the older generation IDEs. I don't think that would be a big leap to be able to provide that information as context as inputs to
Yeah.
to your point, right? Because you were saying like the tool is innovation more like, hey, those can like actually empower LLMs with good data, and then there's the people that do cool stuff with them. Like I wonder if this is like the first one, which is like, oh hey, yeah, take a call graph or something, or references if you can be simple, and then use that as kind of like context to hold it.
So how are you verifying when let's just say you like click to generate the reverse caller tree, and how are you verifying that what is over there is trusted or untrusted data?
I'm not.
Yeah, so I'm saying I think that problem is a little bit harder than he made it sound because you have to evaluate what is is that that caller present a problem, and the way you would do that is with checking if those APIs themselves are sources of taint, or you'd ask an LLM, is it a source of taint? And so you're gonna need to. I don't see that as being computationally super easy. I think I have to think about it a little more. But it doesn't. Is it going to execute at the speed of Vibe? I don't think so, because the changes it's making are so rapid and so distributed that I think you're going to need, you're going to be asking that same question a lot of times. I mean, we built static analysis tools for this purpose, hyper-specific for this purpose for 20 years, and they still constantly have false negatives. And so, like, the idea that, I don't know, that's going to be easy, fast, and execute at Vibe speed, my knee-jerk reaction is I'm skeptical about that.
It depends on the size of the application. Like, in POC can work great, but not in a large application with many microservices and
If you think about it as like an autonomous agent of some sort, right? You don't necessarily need it to be a Vibe speed, right? Like if I have a sentry bug or whatever, you start out with a sentry bug, and you're like, oh, okay, cool, I've got some issue that's going on here. You can send an agent out and say, hey, go fix this thing. Here's some functions that you can call as an agent to build a call graph or whatever, and then go explore those things personally. It can kind of happen in the background, maybe.
Yeah, hopefully I said it there, and I'll say it again. Like, we're definitely going to need code that scans. We're just arguing about when it happens, right? Yeah. So I'm trying to get there for you, but I really am convinced that that's going to be a separate step. And you're right. Maybe we could multi-thread it and have it be happening in the background, but like the world is changing underneath your feet as you're scanning because you're vibing and vibing and vibing. So we'll see. Yeah. I remain optimistic too, but just not that that's the path. But I'm excited.
Yeah, I'm just curious. Do you think large language models will eventually just self-solve themselves? Because obviously for a developer, you have to train them on secure coding guidelines and do developer training, but an AI can keep those in mind while you're vibe coding. Do you think that could potentially be something that happens?
That's not been my experience so far. If I try to put, I think you make it work for a POC, but I think so. I've seen this with my own eyes, where the secure, like I used XML external entities as an attack class example in the deck. The default XML library in Python is called XML, and like the safe version from the community is called diffused XML. And so when a developer sees that option, which one are they going to pick? They're going to be like, what the hell is diffused XML? And like, I don't want any part of that. And so I just think developers will vote with their feet for the code that is the most self-explanatory, regardless of the security. And if you're explaining, then you're losing. And so I think they're just going to give the people what they want. And then I think maybe, again, like after the fact, when it comes time for your review process, like you get results from your tools and your peers or whatever, I think that will be the time to do it. But I think trying to do it in real time, you're just going to be, there have been tools, by the way, that in your IDE will suggest secure versions of APIs. And if you can go to the marketplace for the IDEs, and like developers voted with their feet a long time ago. They don't give a shit about your security tools in the IDE. Like they don't want them. And that's because you want to be in flow state. You just want to be focused on your feature. And so I think going a little bit against the grain to try to like teach them security in that process in that way, that's not where they're looking for feedback. So I think, what I think, if I try to riff on that a little bit, I think it's interesting for AI might be more receptive to AI security changes because like it can reason about them more quickly and more rationally than a human would. But yeah, interesting world we're getting into. Cool, thank you.